Episode 26. I know I missed Saturday. Sorry, my fault. But let's just get into it.
So let's make one. Let's create a new scene. And since this is an of making changes,
This is your brain
Okay, I actually
and this
meant
is
to
your
look this
brain
up.
when you're in the zone.
until you're set.
I actually meant to look this up, so I will just get it ready here. Like, I watched that ad for the first time not too long ago, like a few days ago. And, I mean, it looks kind of interesting. Does it even have an app? Yes, it does. Alright, let's get it.
Satisfied. Enemy. A proper hero, of course, needs a good enemy. So let's make one. Let's create a new scene.
Okay, and let me just try this on my own for now. Let's see, am I going to... Do I need this? I don't need this, and I don't need this. I don't need that. And I can just open all these, right? Yeah. Yeah, nice. Okay, gonna just do... What is it? Animated sprite, or do I do... Wait, do I do animated sprite or regular sprite? Okay. I guess animated sprite, yep. Actually, let me think. What was the... What's the one you put on a... Like, what did I have there before? Character body. Okay. Is that what I want? I don't actually know. I'll just follow the tutorial.
And since this enemy doesn't need to collide with anything, we can just go ahead and use a Node 2D as the base. Let's also add an animated sprite. Let's create a new scene. And since this enemy doesn't need to collide with anything, we can just go ahead and use a Node 2D as the base. Let's also add an animated sprite. So I'll search for animated sprite 2D. Let's go to animation and...
Doesn't need to collide with anything. That's not true at all, though. That's not true.
Some new sprite frames. Select them, and let's load in from the sprite sheet here. In the pack, there's both a green and a purple version of the enemy. I'm just going to choose the green one. And this is a 4x3. And I've included 3 animations here. One for the enemy kind of waking up, an aggressive idle animation, as well as one where the enemy takes damage. So I'll use the idle animation here. Let's add these 4 frames. Let's hit F and zoom in. I'm also going to move this up. Set the animation to autoplay and the FPS to 10. And now if we preview, we have these 4 frames. Let's hit F and zoom in. I'm also going to move this up.
Half?
Set the animation to autoplay and the FPS zoom in. And the idle animation here. Let's add these 4 frames. Let's hit F.
Oh, I see. Oh. Okay. Sure.
F and zoom in.
I just want to
I'm
see
also
what
going to move this up.
Just want to see what he does here because it does need to collide with things.
Set the animation to autoplay and the FPS to 10. And now if we preview, we have an animated slime. And this is where things get really cool. Because we made our kill zone into a reusable scene, we can simply use it for our enemy as well. So at the top here, I'll add in a new scene. I'm going to select the kill zone. And now all we need to do is give this a collider. So Control A, search for a collision shape. Let's add in a rectangle. Fit it to fit our enemy. By the way, I'm holding down Alt to scale uniformly. And with that, we can simply rename. By the way, I'm holding down Alt to scale uniformly. And with that, we can simply rename our top node here to slime and save it as a scene. Now in our game, we can drag it in, scale uniform.
Okay. Sure, I guess that's... You don't need to put a 2D scene there, though, like... Whatever. 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 Sure. You know what? No, I'm gonna do ooze because it doesn't really look like a slime. I'm not gonna lie. Okay, sure. What? Where's the play button?
Formally, collider, a usable scene. We can simply use it cool. And now if we preview, we have an animated.
Okay. Sure. Like, you don't... Whatever. Whatever. And can't I just do... What is it? This? Can I just do this?
Games where the enemy takes death and the we're going to search for kill zone enemy as well. So at the top here, I'll add in a new scene. I'm going to select the kill zone. And now all
Okay.
we need to do is give this a collider. So Control A, search for a collision shape. Let's add in a rectangle. Fit it to fit.
Huh. Okay. Sure. I see. Sure. I guess it doesn't really matter where I put that exactly. Perfect.
Fit our enemy. By the way, I'm holding down Alt to scale uniformly, and with that, we can simply rename our top node here to slime and save it as a scene. Now in our game, we can drag it in. I'm going to place it over here. And if we play now and move to the enemy, we can see that just by throwing together a couple of nodes and reusing our kill zone, we've successfully added a new element of danger to our game. If we enter the enemy, we can see that indeed our game restarts. Of course, currently dying doesn't look very exciting. We'll fix that in the next chapter. But first, let's make our enemy move back and forth. We could, of course, do this using an animation player, just like we did for our platforms. However, I think it would be cooler to make a script that moves our enemy to the right until we get close to a wall, in which case it changes direction and starts moving left. This way we can simply drag and drop the enemy between any two walls in our game, and our script will do the rest. So let's start by making our enemy move to the right. So I'll go into the slime, add a new script, use the default template, and place it under the scripts folder, and hit create. Let's get rid of the ready function, and instead we are going to be using process.
Okay. Sure.
Just like movies, video games display motion by drawing frames and showing them in quick succession. While movies show frames at a fixed rate, most often 24 frames per second,
true.
video games generally try to draw as many frames as possible to get a smooth result. How often this happens will depend on the system the game is running on and what is happening in the game. But unless the game is lagging, it should draw a new frame at least 60 times per second, and often much more. Before the computer can draw a new frame, however, it first has to update the state of the game. What has happened since the last frame? It does this for all the nodes in our game. Then it draws the new frame. This is referred to as the game loop, because it happens over and over again, and it is really the driving force of our game. Godot, of course, does this automatically. But this is referred to as the game loop, because it happens over and over. This happened since the last frame. It does this for all the nodes in our game. Then it draws the new frame. This is referred to as the game loop because it happens over.
That's not what a game loop is, but okay. I guess technically in game engines, that's what the game loop is.
Over and over again, and it is really the driving force of our game.
But not in game design.
Godot, of course, does this automatically, but we can add functionality to the game loop using the other function in the template, process. Unlike ready, which only runs once, process runs every frame. This makes it perfect for doing things over time, such as moving an enemy. We simply make sure to change the position of the enemy a tiny bit each frame. So in our script, we can simply remove the pass keyword and instead access the position of our slime, more specifically the x-coordinate of our position, and add 1 pixel to this every frame. Then in our game, let's go ahead and place a slime close to our player so that we can see this happening, and play. And as you can see, the enemy just shoots past us on the screen. And as you can see, I'm close to our player so that we can see this happening, and play. And as you can see, the enemy just shoots past us on the screen. Now, one problem with this that might not be obvious, other than it's moving way too quickly, is that we are increasing the X position every frame by a fixed amount. And because our frame rate can vary, this means that the enemy will sometimes move faster than others, which is not very good. To fix this, we use this little thing here called delta. Delta is the amount of time that has gone by since the last frame.
Yes.
If we're drawing many frames per second, delta gets really small. And if we lag out a bit and are not drawing as many frames, delta becomes bigger. Because of this, we can use delta to compensate for variations in frame rate. If we have a high frame rate, we want to only move our enemy a little each frame. And if we have a low frame rate, we want to move it a lot. In other words, we can multiply our movement by delta to make it independent of the frame rate. Now, delta can be a bit hard to wrap your head around at first, but don't worry, you'll get the hang of it. A good rule of thumb is that whenever we have a speed value that we can adjust, such as our 1 here, we should probably multiply it with delta. So in our script, we simply go plus equals 1 multiplied with delta. Now, what this essentially means is that we're going to be moving 1 pixel per second, which is not very fast.
Okay.
So let's instead change this to something like 60. And we can actually store this speed in a constant at the top of our script, just like in the movement script. So here I'll write const speed and set it equal to 60. Then we can simply use speed here instead of hard coding the value. This makes it easy to change constants right at the top of your script. And now if we play, we can see that our enemy is moving at a reasonable rate, and we know that this speed won't change from system to system. So let's get rid of this extra slime here, and instead make this one actually change direction whenever we face a wall. To do this, we need a way to control the direction we're currently moving in. So let's create a variable that does
It's not speeding up.
this. We'll create a var, call it direction, and set it equal to 1 by default. Then if we need to go in the opposite direction, we'll set it to -1 instead. And to actually apply this, all we need to do is multiply it into our speed. So we'll go direction times speed times delta. This is a really standard way of doing movement. we simply add onto our position in a direction multiplied by speed and delta. So now all we need to do is check if the enemy gets close to a wall. And for this, we'll use a new type of node, the raycast node. Raycasts are invisible rays that we can shoot out to detect collisions. So inside of our slime here, let's add a new node of type raycast2d. And as you can see, it draws an arrow to represent this. Let's move the starting point here to the center of our enemy. And let's have it shoot out to around here. I'm going to rename this to raycast right. I'm then going to press Ctrl D to duplicate. I'm going to have this shoot out in the opposite direction and rename this to raycast left.
Okay, sure. What? That doesn't work. That doesn't work. I forgot. Wait, what?
Let's move
Wait,
the
what did he
collision
do here?
that does this. We create it. Then if we need to go in the opposite direction, we'll set it
Don't like how
to
long that takes to
-1
update.
instead. And to actually apply this, all we need to do is multiply it into our speed.
But
So we'll
that's
go
fine.
direction times speed times delta. This is a really standard way of doing movement. We simply add onto our position in a direction multiplied by speed and delta. So now all we need to do is check if the enemy gets close to a wall. And for this, we'll use a new type of node, the raycast node. Raycasts are invisible rays that we can shoot out to detect.
Okay. Can I do that? Yes. Got it. Oh. Interesting. Okay. Sure. And I guess I'll just, it doesn't really make sense to change the naming here. Sheesh, bro. And why is that so? Like, why? Yeah, why is that so long, bro?
Collisions. So inside of our slime here, let's add a new node of type raycast2d. And as you can see, it draws an arrow to represent this. Let's move the starting point here to the center of our enemy. And let's have it shoot out to around here. I'm going to rename this to raycast right. I'm then going to press Ctrl D to duplicate. I'm going to have this shoot out in the opposite direction and rename this to raycast left. Now in our script, we can reference these nodes just like we did with our timer. We simply select them both, click and drag, and hold down Control while releasing. As you can see, this creates two variables, one raycast right and a raycast left. Then every frame before we move our slime, we will go ahead and check if we're currently colliding to the right or to the left. If raycast right dot is colliding, if this raycast is hitting something, well then colon, and then make sure to indent here with the tab. We will set our direction to be -1. If we are colliding on the...
What? Why not just... I don't understand why you put it in a variable. I don't really get that. I don't know what this is either. At on ready. Oh, I see. I know what it is. Sure. Dollar sign. Wait. Oh, yeah. Okay. No. Sure. I don't really need to do that. Okay, and then do I do else or do I just do another if statement? Guess it doesn't really matter. I'll just do another if statement. Okay, I'm not sure how much I like the dollar sign. Oh, also this is right, and this is left. Ah, amazing. I don't know what I'm doing. Oh, this doesn't work for walls. Or this doesn't work for ledges. Yeah, I don't have any walls. I don't have it. I don't have any walls. So, I'm just gonna change these a little bit here. What do I do here? I think I can do this, maybe? That should be fine, probably, I think. And this should work, I think, right? Now I have to be a little bit precise with this. What? Okay. Sure. Just put it there. Put one here. And what did I actually set the hitbox to here? Um, hmm. Tile shape. Square. I like forgot. I completely forgot actually. Layers. Yep. Um, Output debugger. No. Um, Tile map. Tile map. Nope. No, no, that's not it. Physics, layers. Resource. Huh. Someone is calling me. Okay, what? I thought there was an easier way to edit this. Oh, yeah, there it is. Never mind. Okay, pretty good. So, yep, it does it right there. Mm-hmm. Mm-hmm. Okay. Pretty good. Yeah, nice. Okay. So then we do this here. And yep, that's fine. And then let's add another one. Woo 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 woo. I like the wrapping. Wrapping is kind of cool. And then I'll put this one here. Sure, why not? Okay, great. And let's see if it works. Or if I failed. Okay, great. Nice. That was weird. What the fudge was that? What is going on? That's bugging. Okay, yeah, that's weird. Yippee, it works.
the right, we want to move to the left. And we'll add another one of these if statements. So if raycast, you guessed it, left, dot is colliding, well then we'll set our direction back to 1. And that's it. Our enemy is now ping-ponging back and forth between the two walls. And this is happening completely automatically through script. Really cool. Now, the only thing that is left is to flip the enemy sprite when it changes direction. Luckily, if we go inspect our animated sprite here, under offset, we have this flip H property, which will simply flip the sprite. So let's control this through our script. In our script, we'll get a reference to our animated sprite 2D. This creates a variable called animated sprite 2D. I'm just going to get rid of the 2D here to make the name a bit shorter. And then whenever we are colliding on the right here and we change direction to move towards the left, we will also go to our animated sprite and set the flip H property to true. And when we're colliding on the left and we're changing direction again, well then we'll go to our animated sprite and set flip H back to false. And
Why is it H? What? I'm confused. So why is it offset? What? Oh, horizontally, I see.
that's it. That's our entire
I see. Okay. And then, I can just do this, bro. It doesn't matter. Please! Please. Why does it not? Okay. Nice. Okay, why does it do that? What happens if I just... What the fudge? What happens if I just do that? Yep, that's not right. Okay. What? Oh, that's not gonna work. Okay, I see. I see why he did that then.
script. Let's
I see. I see. Bruh. Bruh? I want it to... Okay? What? Why can't I do that? Thank you. Poggers. Got it. Okay, fair. So now I can just take all of these out. Sure, that's fine. What? Sure. I mean, I guess it doesn't really matter then. Oh, the only issue is that it's gonna... Okay. That's the only issue. That's fine. Okay, yeah, sure. That is so weird. I don't know what the fudge that is. I don't know what's going on there. Sure. What? Oh, I see. Yeah, that makes sense. That makes sense. Oh, what the fudge? Okay. Weird. Weird. Okay, no. What the f... Why? What? Oh. Okay, now does that work? No. I think I messed something up. What a crazy concept. Okay, wait, what? Sprite? Yeah, sure. Okay, yeah, that's fine. I guess that should be fine, I think. Okay. Why? Come on. Wait, why? Whatever. It's fine. It's just I edited it, so it's a little weird now. Nice. Now let's try it out, baby. Okay. I don't know what the fudge is going on now. Pretty good. That's what's going on. That's what's going on now. Can I move this script? Um, GD script, path. So if I do this, then I do this. Nice. Now I can delete that. That's fine. Beautiful. Now if I do this, great. Okay. Now if I do this, should work, I think, probably. What? Okay, please work, please work. Okay. Bruh. Do I really have to fudging? Okay. You know what? I don't even want to do this. I don't even want to make variables, you stupid. Stupid rupid. There you go, perfect. Now let me... Okay, yep, sure. Now should work, I think. Yep, should work. Yippee! So now I can actually do the same thing with my knight. I just have to actually change it. Oh. Oh! What? Ah! Please! Okay, I don't know what the fuck. Uh, what? I think I can do this, maybe? Hmm. There you go, then. Was it animated sprite? I'll just do this. That's fine. No. This one. Thank you. Yeah, that's fine, I guess. Should I do Altif? Nah, I'll just do a regular. Flash. Okay, pretty good. That should work, I think. Probably. Easy. Ah. Yeah, I don't know what that visual bug is. Like, what is that? What is that?
Find our enemy here, and hooray, we've made an enemy, and a slimy one at that. But of course, dying to the enemy could definitely look cooler, so let's fix that.
Want to learn skills for the future of automation? NASCAR Technical Institute's
Okay, I think that's
Robotics
it.
and Automation Technician
good enough.
program.
Dying 2.0.
How many minutes is this? Oh, this is like less than... This is less than 2 minutes. I guess I'll just do this.
Let's start by adding a slow motion effect when we die. We can do this by changing the time scale of the entire game. So inside of our kill zone, we'll open up the script here, and right after we print you died, let's modify our time scale. So I'll go engine, dot time scale, and set it equal to 0.5. This means that we will go at half speed. Then when our timer runs out, let's set this back to default, because otherwise we will actually still be slowed down when our scene reloads. So we'll go engine, dot time scale, and set it back to the default 1. And if we play this now, this is actually already much better. Notice that it also takes twice as long before the game restarts, because everything in our game slows down, including our timer. But I think it could be even cooler if we remove the player's collider to make him simply fall off the map. To do this, we need a reference to the player. We actually already have this here. You'll notice that after the onBody entered here, there's a variable called body. This refers to the body that entered the area. And since the only thing that enters the kill zone is our player, body is our player. So we can actually add a new line here that goes to our body, and then we simply need to get the collision shape node under our player. So we'll do dot get node, and we'll search for the collision shape 2D, and we can remove it. So we'll call dot queueFree on that node. Again, queueFree means to remove that node. So here we're accessing our player, getting the collision shape node, and removing it. And now,
Okay.
if we find our way to some danger, boom, we are hit and we fall off the map. Q, if we find our way to some danger, boom, we are hit and we fall off the map.
But... What?
Q, if seeing our player.
Oh, I see. I see. Okay, I see.
Getting the collision shape node and removing it. And now if we find our way to some danger, boom, we are hit and we fall off the map.
That's an interesting way to do it. So what he's doing is he's removing the collision box so the character doesn't touch the ground anymore, which makes it fall off the map. That's an interesting way to do it. That's an interesting way to do it. Definitely not the way I would do it, but that's okay, I guess. Oh, this is not it. This is not what I wanted. Yeah, okay. Yeah. Wait, I can just go directly into the script, I guess. I can just do that. What? It's right there. Oh, underscore body. Whoops. Underscore body. Why? I don't want the underscore there. That's fine. Yeah, I don't want the underscore. I don't need to do it twice. Oh. Okay. I see. Uh, good. What did he do? Hmm. I guess. Hold on. I guess I don't. Yeah, I guess I can just do this. Just copy this, and then I can do. Right? I dislike that. I really dislike that. Why? What is going on? What is happening? Honestly, this part seems more intuitive than Unity, for sure. Well, actually, is this in Unity too? Yeah, it is. Never mind. Never mind, never mind, never mind. What? 28. Okay. Nice, it just breaks. I'll figure it out later, that's fine. I'll just do it his way, that's okay, whatever. Nuts.
Cue the sound effect. Wah! Player 2.0.
Crazy. Okay, yep, that's it for this video. Thank you so much for watching. That should have been episode 26. And you will all see me tomorrow.